Welcome to The Explainer. Today, we're going to talk about a concept that's basically a blueprint for writing smarter, cleaner code. It's called inheritance.
All right, so let's just jump right in with a question. And it's a question that really gets to the core of why inheritance is such a big deal. Why is it that programmers, really hate repeating themselves? It seems simple, right? But the answer uncovers a huge principle in writing good code.
And to answer that, we need to talk about something every single programmer, I don't care who you are, has fallen into. It's what I call the copy-paste trap. You know the one. It feels so fast, so efficient at the time, but man, it almost always comes back to bite you.
Okay, so picture this. You're building a program, and you need to represent a doctor, a footballer, and a businessman. What do they all have in common? Well, they're all people, right? So they all have an age, a height, a weight. They can all talk, walk, and eat. If you're not careful, you'll end up writing that exact same code for each one, 3 times. That's a lot of repetition.
And this is where it gets really messy. Let's say you need to change how the walk action works. Now you have to hunt it down and change it in 3 separate places. And what if you forget one? Boom, you've just created a bug. It's not just inefficient, it's a disaster waiting to happen. There has to be a better way, right?
Well, there is. And that solution, that smarter way, is a beautiful concept called inheritance. This is our elegant escape from that copy-paste nightmare.
So what is it exactly? In the simplest terms, inheritance lets you build a new class on top of an existing one. Think of it like this. The new child class just automatically gets all the powers and abilities of the parent class. No extra work needed. You write that code one time, and then you can reuse it over and over again.
The whole thing is built on this really simple, intuitive idea from the real world. We call it the is-a relationship. A doctor is a person. A dog is an animal, right? It just makes sense. This is the simple test that makes inheritance so powerful and, honestly, so easy to grasp.
And here it is, the big reveal, the before and after. On the left, you've got that mess we talked about, all that repeated code, but look at the after on the right, so much cleaner. We create one single person blueprint. We call this the base class, and we put all the shared stuff in there. Then our doctor, footballer, and businessman classes, they just inherit all that goodness from person and only add the things that make them unique. It's just so much better. Clean, efficient, and it just makes sense.
Okay, so now that we've got the basic idea down, let's dig a little deeper. Turns out, these relationships can be structured in a few different ways. I like to think of them as different kinds of family trees for your code, each with its own quirks and uses.
First up, we've got single inheritance. This is the most straightforward one you can imagine. It's a direct line. One parent class, one child class. Simple as that.
It's that classic one-to-one relationship. Think about it. A dog class inherits all the basic stuff from an animal class, like, having 4 legs or breathing air. And then it adds its own special dog-like things, like barking.
Next, things get a little more interesting with multi-level inheritance. This is where you get a chain of inheritance, kind of like a family lineage. You've got a child inheriting from a parent, who inherited from a grandparent. It's a whole generational thing.
Here's a perfect real-world example. An IT student is a student, right? And a student is a person. So the features from the person class get passed down to student, and then all of that gets passed down to IT student. The traits just trickle down the line.
All right, now this one is cool. Multiple inheritance. Here, a single child class can actually inherit from 2 or more parent classes at the same time. It's like it's getting the best of both worlds, blending all their features into one superclass.
Think about something like petrol. It has properties of a liquid, like, it flows. But it also has properties of a fuel. It's combustible. It has an energy density. So a petro class could inherit from both a liquid class and a fuel class, grabbing a unique mix of abilities from each parent.
Okay, now let's flip things around with hierarchical inheritance. This is kind of like an org chart or even just a parent with multiple kids. You have one single parent class that acts as the foundation for a whole bunch of different child classes. They all start from the same place, but then branch off to do their own thing.
This is exactly what you see here. Elephant, horse, and cow are all very different, right? But they're all children of the same parent class, animal. They all inherit the basic animal starter pack, and then each one adds its own unique specializations on top.
And last but not least, we have hybrid inheritance. And really, this is just what it sounds like.
It's a mix and match of any of the other types we've talked about. You can combine them to create some really complex, custom family trees for your code.
Okay, so with all this sharing going on, things could get out of hand, right? You've got all these features being passed down the family line. We absolutely need some rules. We need to control who gets the keys to the car, so to speak. Who gets to access what?
The best way to think about this is to imagine your class as a house. Anything you label as public is like the living room. The door's open, anyone can come in, see it, and use it. But then you have stuff that's private. That's like your personal diary, locked away in a safe. It is completely off-limits to everyone outside the class, and I mean everyone. Not even its own children can see it. You use private when you want to be absolutely sure that no one messes with the internal workings of your class.
But what if you need something in between? Well, that's where protected comes in. It's the family-only rule. Back to our house analogy, this is like the family den. It's locked to the outside world, but all the kids and grandkids are welcome. Now, why would you use this? You use protected when you specifically want your child classes to have access to something, to be able to see it or maybe even change it. It's a way of saying, hey, family, you guys can use this.
So, we've gone through the different family trees, we've talked about the rules of the house, but why does all this matter? What's the big payoff? What's the superpower we get from mastering all this?
Well, it really comes down to three huge things. First, you get incredible code reusability. You write it once, and you use it everywhere, no more copy-paste. Second, it lets you build code that actually mirrors real-world relationships, which makes your program so much more logical and easier to think about. And finally, when you put those two together, you get amazing organization and efficiency. Your code is clear, it's easier to read, and most importantly, it's 1,000 times easier to update and maintain down the road.
But you know, a tool this powerful, it's not without its own interesting puzzles. Let me leave you with this question. What happens if a child class inherits from two different parents, but both of those parents inherited from the same grandparent? The child could end up with two copies of the same feature. This is a classic puzzle called the diamond problem. How do you solve that? Well, that's a story for another time, but it just goes to show you how deep and how fascinating this whole world of inheritance really is.